All right, everybody. So this is the Algebra 2 Final Exam Review, Category 6. This is the last video, the last category for the Final Exam Review. You made it. And I'm pretty sure this is my last video for the school year. So that's a good one. That's a good one. Okay. So let's go ahead and get started. We will be discussing other functions, equations, and inequalities today. You'll see here, looking at the descriptors, that we'll be dealing with some absolute values, some rational equations, inverse variation, direct variation is probably going to happen too, cube roots, all that good stuff. We have discussed a lot of these topics in other categories. I did spread them out, especially to categories 1, 2, and 3. Like I said, those are really front-loaded to be sure that we didn't fall too far behind. So let's go ahead and get moving on our first problem. So let's go ahead and work this problem out here. It says a kayaker spends an afternoon paddling on a river. She travels 3 miles upstream and 3 miles downstream for a total of 4 hours. In still water, no current, the kayaker can travel 2 miles per hour. The solution C to the equation below represents the average speed of the current river. So what I'm going to do is I'm going to kind of just sketch this out real quick. What's that river look like here? Let me draw my little kayak. So if the kayaker goes upriver, which means she's going against the current, right? And let me draw that current there, right? If the current is pushing her back this way, she's got to be able to go, right? And so it's making it a little harder, but then eventually it'll be easier for her when she starts coming down current, okay? And so those are the situations that we have there. Now, what ends up happening here is they want us to prove which statement is true off of this equation that's given us 3, 2 minus c plus 3 over 2 plus c equals 4. Okay? So when we have this here, they want us to prove which one of these statements is true. So it says c equals plus or minus 1. Our solution, since finding the least common denominator yields negative 4c squared equals negative 4. Maybe, we haven't proved it yet, maybe. B says c equals plus or minus 2 are not solutions since they would result in a 0 in the denominator for 3 over 2 minus c or 3 over 2 plus c. That's a possibility. C equals negative 1 is not a solution since the speed of the current cannot be negative. That is not true. It can be negative, especially if it's pushing against us, so we can eliminate that. C equals negative 1 is not a solution since the time cannot be negative. This C is the current, the speed, so that's no good. So that's incorrect as well. So we got to test these two. If we were looking for common denominators, okay, and we can just do this very quickly. We know that we can multiply this by the conjugate of the other term, which would be 2 plus c over 2 plus c. I'm doing this because I want to be able to add these two fractions together, and I would do the same thing over here, but I would multiply by 2 minus c on both sides. Okay, and so what ends up happening, long story short here, is we would get 3 times 2 plus c over 2 minus c times 2 plus c plus 3 times 2 minus c over 2 minus c times 2 plus c equals 4. So now these are our common denominators here. If I was to multiply these two common denominators, you could do the box method. It is going to end up just being a difference of squares. So we'll do this pretty quickly here. We'll have 2 minus c times 2 plus c. 2 times 2 is 4. We get a 2c. We have a negative 2c and then a negative c squared. So we know that these two terms would simplify out and we're left with 4 minus c squared. If we set this equal to 0, okay, we get 4 equals negative c squared. And so this statement alone proves that A is wrong. Okay, like it's not plus or minus 1, it would actually be plus or minus 2. So A is no good. B says 2 and negative 2 are not the solutions because they would result in 0. And that's true because if her speed is at 2 and she's being pushed at a rate of 2, that means that she actually wouldn't go anywhere. She wouldn't be able to paddle at all. She would just stay still. So B here has to be the answer because 2 is just, the current is too fast. So it can't be 2. It doesn't have to be 1. It doesn't have to be negative 1. It just can't be 2 or negative 2. It actually couldn't be any greater than those values either because it would push her too fast. A lot to think about. Think it over. Draw your sketches and all that good stuff. This one here, I just want you to add these two expressions. And so you're going to have to multiply by the conjugates like I did on the previous problem. Do your best on this. Look at the last slide how I did it. If you have any questions, send me a message. Okay, here it says, what is the sum of the two solutions for the equation given below? The equation is negative 36 over t plus 4 plus t plus 9 equals 5. Wow, okay. If we did this by hand, it would take a lot of work. Remember, this is a timed exam, and you really only have like 3 minutes of questions, so you don't want to utilize your time trying to work this one by hand. What I did here is I plugged it into Desmos, and I got a solution here at negative 10, and my other solution here is at a positive 2. All right, this is where we crossed. This is where we crossed. Okay, so at a negative 10 and a positive 2. So these are our two answers when we add them up, because the question is asking us to give us the sum of the two answers. Okay, negative 10 plus 2 is equal to negative 8. And this is our answer, negative 8. They put 2 in there as a possible answer because 2 is one of the solutions, but that's not the answer. 8 had nothing to do with this, and neither did 12. You would only get that as if you did the addition incorrectly. Okay, so be very careful. You're going to use the same skill on this, and I want to know what is the sum of the two solutions. There will be two answers to this. You're going to want to get your two answers using Desmos, and then just tell me what is the sum of your two solutions. Let's go ahead and move on. Okay, here it says to simplify the given expression below. Now this one does take a little bit of time, so let's go ahead and dive right in here. So we have 1 over x plus 5 plus 1 over 5. All of that is being divided by 4 divided by 5 times x plus 5 squared. And so what we have here is we have a fraction divided by another fraction. Well, we know that that is the same thing if we were to take the initial fractions, which is what we have here in the denominator, and instead of dividing by the fraction, we will multiply by the reciprocal of that. What I mean by that is we can take this, we can take 1 over x plus 5 plus 1 over 5 times, and when we take the reciprocal, what I mean by that is we're flipping these two, and we would have 5 times x plus 5 squared over 4. And so now what we're having to really just do is just distribute our values in here. Don't try box methoding this out. Don't do anything like that. Don't try reducing anything. Leave everything as it is, because it'll make more sense in just a bit. So if I take this value and I multiply 5 times x plus 5 squared over 4 times 1 over x plus 5, what I'm going to get here, and let's do that work up here, we would get 5 x plus 5, all of that squared, right? Because we do numerator with numerator, and so it's just 5 times x plus 5 squared times 1 stays the same, over 4 times x plus 5. So that's the first term. The second term, we do the same thing. It'd be 5 times x plus 5 squared times 1. So we'd have 5 times x plus 5 squared over, okay, 5 times 4. And I'm going to leave them in terms here. And you'll see why in just a bit. Okay. So what I want to do before I can start combining these together, I want to see, are there any factors that I can simplify out? Well, 5 and 4, no, that stays the way it is. I have x plus 5 squared. That means I have two of these essentially, so I can take out one of them and simplify it out with 1 here in the denominator. On this term over here, I can actually simplify this 5 with this 5 here. So check it out. What we're left with is 5 times x plus 5 over 4 plus, okay, this x plus 5 squared over 4. So now I can really add these two up. Okay. What I am going to do, though, is I'm going to start, because I can already see here that we have some nice factors that are going to come out here. So what we're going to want to start doing here is distributing this work in here. And we're going to want to box method this numerator out. Okay, so when we do that, we're going to get 5x plus 25. Okay, now both of these are over 4, so we can already start combining these. We're going to put everything over 4. When I box method this out here, I'm going to get a plus x squared, a plus 10x, and a plus 25. What we want to do here is we want to start combining our like terms. We know that we can combine these 25s together and these values together. And so what that leaves us with is x squared plus 15x plus 25 plus 25 is 50 over 4. Okay, so this looks already a whole lot nicer. This did take a lot of work, okay? But you'll notice here that we have a trinomial. Like always, in all the reviews that we've been doing all year, we should always try breaking down these trinomials into two binomials. X times x, we're looking for two numbers added or subtracted that give us 15, but multiplied give us 50. Well, that'd be a plus 5 and a plus 10, all of that over 4. Because 5 plus 10 is 15, 5 times 10 is 50. So that means that our answer has to be B. This is a very involved problem. I really like this problem, though, as it really pushes a lot of your skills as far as understanding how fractions are working, distribution, multiplication, factoring, simplifying, the box method, all that good stuff. Everything is happening in this one question. This is the way you would approach something like this. So give it a shot. Watch this part of the video again if you need to. Watch it again. I think it would be super helpful if you did that. Okay. All right, let's go ahead and move on to the next one. And so you have one very similar to this. All the steps are actually going to be the same. The only difference is the numbers, but you will get very similar answers to this one. Take your time and look at how I did the last one. Okay, if you have any questions, send me a message on Teams. All right, so let's go ahead and look at this one here. It says, which of the following is a complete list of discontinuities of the graph f of x? So it tells us here, okay, it tells us here that that we have f of x equals x squared minus 9x plus 14 over x squared minus 4. So when we're looking for these, we already want to start breaking down into factors. So in this numerator, I know that I get x and x. I want two numbers added or subtracted that give us negative 9. And multiply gives a positive 14. Well, that would be a negative 7 and a negative 2. Divided by x squared minus 4. We've seen this several times this year. We know this is a difference of squares. That would be x times x. To get that negative 4, it would be a positive 2 and a negative 2. And we saw this very commonly in our Unit 9 review and Unit 9 lessons. immediately we see that the x minus 2's can simplify out. Once they're simplified out, we know that that's going to end up being a whole. And it's going to be a whole at x minus 2 equals 0. So at x equals 2. We have some type of whole there. Okay, and this is our removable. We removed it, it's removable. Okay, because it's removable, we do have removable discontinuity. So that means that this guy here is wrong, this is wrong, so we can already eliminate those. We see here that C and D both have the same horizontal asymptote, they both have the same vertical asymptotes. The points are different. Well, let's prove these. I want to make sure that you guys understand how to do that as well. To get the vertical asymptote, okay, we take what was left in the denominator, this x plus 2, and we set that equal to 0, and we get x equals negative 2. This is our vertical asymptote. And so check it out. That is correct. That is correct. Now, how do we get the horizontal asymptote? So to get the horizontal asymptote, okay, we want to look at these rules here, and we're looking at the degrees. And so our degrees in the numerator and the denominator are the same. We have a 2 and a 2. Because these are the same, m equals n, we take the coefficients. The coefficients of this x squared is a 1, the coefficient of this x squared is a 1. So our horizontal asymptote is at y equals 1 over 1, which is just y equals 1. That's correct. That's correct. So then we have these two different points here. How do we solve this? Well, you're going to take the equation that we have. We're going to have this equation of y equals x minus 7 over x plus 2. And we said there's a whole at 2, so we want to substitute 2 in there. We'd have 2 minus 7 over 2 plus 2, and that equals 2 minus 7 is negative 5 over 2 plus 2 is 4. So negative 5 over 4, that's here, which means that C does have to be our answer. So there's multiple layers to this question. It's a really solid question. Take your time through it. Look at these problems. If you have any questions over this, you can always look over your Unit 9 notes, the Unit 9 review, or message me on Teams, and I'll be more than happy to help you guys out. Now we have the same situation with this one here. I'm going to tell you right now, there is a whole, there is a vertical asymptote, and there is a horizontal asymptote. So you want to go through all the steps of how I did all the processes on the previous question. Okay, take your time. Look over the previous problem if you have any issues. So this one here says a constant force, okay, the acceleration of an object varies inversely. So we have direct and inverse variation happening here. So if you remember, direct variation is y equals k times x, and inverse is y equals k over x. Okay, so this one says that we have that it's varying inversely, so we're going to use this equation. So when we're setting this up, it says the constant force, okay, given a constant force, the acceleration of an object, so the acceleration A, okay, varies inversely with the mass. So that means that it's going to be k over m, where a is the acceleration, m is the mass. Assume that a constant force is acting on an object with a mass of 6 pounds. So they're telling us that m is equal to 6, and it results in an acceleration of 10. A equals 10. Okay, they want to know the same thing when the mass is 12. So I got to find this k. K is what we're looking for. So to do that, we're going to plug these values in. We're going to say 10. Okay. 10 equals k over 6. And then we're going to multiply both sides by 6. So we get 60 equals k. I'm going to underline that. That's important because we're going to use this now as our equation for a equals 60 over m. And we know that the mass now is 12. So when this happens and we plug all this in, we get that a equals 60 over 12, which equals 5. A equals 5. So our answer here would be D. Okay, and this makes sense. Okay, if we're able to move an object, okay, and it's a light object, we should be able to move it faster, right? And it's a heavier object in this case, right? We went from a lighter object from 6 pounds to 12, so we should be able to move it a lot slower because the mass went from 6 to 12. So then the acceleration goes from 10 to 5. Pretty interesting. Okay, let's go ahead and move on. You guys have about the same situation here. We have all the same scenario, except we have different numbers here. So make sure that you take your time with this one. If you have any questions, refer to the previous problem or message me on Teams. And then lastly, we have this question here. It says a skateboard manufacturing company has a fixed cost of $50 per day to operate a production facility plus $450 in cost to produce 70 skateboards per day. Which of the following expressions represents the average cost C per skateboard if the company produces X skateboards per day? So typically the way we'd see this is we'd see it as like Y equals, they give us this rate, which is kind of like our slope. It'd be 450x over 70 plus a constant of $50 a day. Okay, but they want to know how much is this per skateboard. So really what's happening is we would take this equation and we'd have to divide it all by X. Why are we doing this? Because we're figuring out how much is this, because this just gives us the money. We want how much money per day, which is X. And so we come up with this fraction over fraction situation. Okay. And so really what happens here is we can pretend like this is an X over 1, and this gives us a situation similar to a problem we had earlier, where we had 450x over 70 plus 50. All of this is now being multiplied by the reciprocal. Okay, so we'd multiply it by 1 over x. When we do this, we're distributing numerator with numerator, denominator with denominator. And what we'd end up getting is 450x times 1 is just 450x over 70x plus 50 times 1 is 50 over x, right? Because this is really 50 over 1. So now we want to add these up, but I can't. I can't add these up yet because I don't have common denominators. So what I want to do here is I'm going to multiply this guy by 70 over 70. I'm not changing the value, I'm just changing the way it looks, because 70 over 70 is 1. So what happens here is we have 450x over 70x plus 50 times 70 is 300, or I'm sorry, it's the 3,570. I'm sorry, 3,500 over 70x. 3,500 over 70x, yeah, because 50 times 70 is 3,500. X times 70 is 70x. And so now what we're able to do here, okay, is we can combine these. Before we do that, we can actually simplify these out a little bit. No, let's do this first. Let's go ahead and just add them up. We say 450x plus 3,500, all of this over 70x. Now we see there, like, that doesn't match any of these here. Well, the issue is what they did is they factored out 10 from here. And so what we can do here is we can factor out a 10 from this numerator, which leaves us with 45x plus 350 over, and they factored out a 10 also, times 7x. The 10s would simplify out, and that leaves us with 45x plus 350 over 7x. Then this would be the equation to solve for how much it costs per skateboard a day. So we look at our answer choices here. Well, 44, no, that's not right. 45x, no, plus 350, yeah, this 8 is wrong. 55, no, so 45x plus 350 over 7x, there we go. So it's a lot of work with the multiplication of it, but you guys will get the hang of it. Please make sure that you take your time on this problem, as you're going to get one very similar to it on the next slide. So here we have the exact same scenario, just different values. I want you guys to practice going through the motions. If you have any questions or concerns, let me know. Send me a message on Teams, and I'll be more than happy to help you guys out. And that's it. This concludes our Category 6 video. Finish this one up, and congratulations, guys. We'll see you all later.